Okay, here we are on the game again. I realize you're still having some trouble, so I'll do one of each of these so that you can get the gist. It's all about simply knowing the graph motion. First thing though, make sure it is in input mode. If it doesn't say input mode up there, you need to click down here on it. Because if it's in control mode, then you're not doing it right. You got to move the person around. Make sure it's in input mode, click on there. All right, we're going to start again with position versus time. And let me go ahead and reiterate back on our other ones. So this is the one I did on the video before. So you have the little person down here, they're on a number line, position on their line, right? They can move left or right. Position is equal to the position you find here. Time is the amount of time that elapses as they move. In this one, you need to figure out the slope, and then you can tell if it's moving or not. I'll give you a hint. A straight horizontal line is zero slope, so zero velocity, meaning zero movement. So we just need to note where they're moving. And we can do that by putting little markers and see at that marker, you can see at 0 seconds, the character's at 2 meters. So we're going to go and take the character and move them to the 2 meter mark. Okay, all that is I've now set up the position of the little character to do the motion, which is not moving at all, sitting still at 2 meters, because that's what the green line indicates. After that, I hit play. And you see it traces along that the character did not move, okay? Now, in this one, we have at time blank set velocity. You need to understand that velocity is a slope. You notice that it doesn't have a slope the entire time. In fact, for 1 second and 2 seconds, the slope is 0. We can see that by calculating and doing the points. See how it doesn't rise at all, it just runs? Well, that means there's no slope. So that means for 2 seconds, it's going to sit there still. But at the 2 second marker, it's going to start to move up. It now has a slope. So we go from 2 seconds at 2 meters to, by the time we get over here to 3 seconds, we're at 4 meters. So what this means is I went up to 2 meters, right? And then I ran 1 second. Remember that our slope is rise over run, which is going to be 2 meters over 1 second, which is going to get 2 meters per second, which is a velocity because the slope is a velocity for a position versus time graph. Now, since we know the velocity starting at 2 seconds, we can start to put that in. First, I'm going to go here at time. What time did this velocity start? The velocity started at 2 seconds. So I'm going to click on that, and it allows me to pick 2 seconds. Okay? What velocity does it need to go? Well, we already calculated that it needs to go at 2 meters per second, starting at that 2 seconds. So over here, I'm going to put it at 2 meters per second. So there's my 2 meters per second. I also need to note that the motion starts at the 2 meter marker. Luckily, my character is still at the 2 meter marker. If he wasn't, I would need to move it there. Now that everything's set up, I can go back and I can hit that play and it'll trace it out. Now, For this one, it has a different slope, right? You can see that this has a different slope than we had before. It starts at a different point because we can see where the position is. And look, it stays at that velocity for the entire time. So where do we need the velocity to start on this one? Well, at 0 seconds. So you're going to have to mark there 0 seconds because that's where this slope begins. And a slope on a position versus time indicates velocity. And then you're going to have to use your little points that you can do it by clicking on it to figure out how much it's rising and running or what your slope is based on those points so that you can then enter in the correct velocity here before getting it to move. All right, so that's position versus time graph where all you do is set velocity. Velocity versus time. Now, it can be a little bit more difficult because a lot of people have trouble understanding things like this right here. So I'll show you this one. So you can see that it's not moving. It has a 0 velocity here because remember, a velocity versus time graph, it's only going to have a slanted line with a slope if that slope is an acceleration. Right now we're setting velocity, so we're just worried about velocity. So at 0 meters per second for the first 2 seconds, it's not moving at all. It's going to sit still. However, we can see right up here that it starts to move at the 2-second marker. That means at 2 seconds is where I'm going to need to mark on this one. I need to have some sort of velocity. What velocity? Well, look, it's 3 meters per second is right in the center of that mark. And I bet if I carry down, it stays on that since it's a straight horizontal line, 3 meters per second. So that's what I need to set this down here for. I need to set it for a positive 3 meters per second. But I'm not done yet because the thing that a velocity versus time graph doesn't show you is a starting position. Notice we still have our position here. You have to infer, all right, well, if it's going to move for 2 seconds at 3 meters per second, that means it has to have enough room to move 6 meters because that's what that is, right? So if I move 3 meters per second for 1 second, that's 3 meters. If I move 3 meters per second for a second, that's going to be added together to be 6 in the positive direction. Positive is always to the right. So if I left my person right here, it would run into a wall because it can't just move on forever. So I need to move it back far enough that it has 6 meters worth to run. So I'm just going to move it back to the 0 because that's easy enough to do. And then I'm going to play it through. Sit still until 2 seconds. After 2 seconds, it moves at 3 meters per second. Look how much distance it took to get through that, so we needed to be careful. This next one would be a negative, meaning it would be moving to the left, so you have to make sure it has enough room to move to the left. Now let's look at position versus time where we set acceleration. Acceleration can be more difficult on a position versus time because we'll have a curved line. But I've already covered that in a number of videos and instructions. So in this one, notice that we're still setting at time, but now we're setting acceleration. Acceleration is the amount of this curve, right? Because that's what that curve would indicate. What that curve is doing is it's a changing slope. So we need to take little looks at what the slope probably is in order to calculate how much of an acceleration we need to do per second. Before we do that, let's note that the motion starts at the 0 meter mark. And I can see that by putting my dot. So I'm going to move my little character down to the 0 marker. Also, notice that the curve goes for the entire time. So I'm going to start it at 0 seconds because the entire thing is curved. Now, I need to start doing some little points. At 1 second, it's a little high up, so it's a little less than 1 meter up. And by 2 seconds, 2 meters up. That's pretty dead center. So I'd almost say to look at this for my rise over run of 2 of those and see that I have to be at least 2 meters per second by that one. And then at 3, looks like I'm almost going 2 now, but it's a little under. And by 4, I'm all the way up at 8. So there might be a little guessing here because you can't calculate perfectly on a curved line. You can just look at about how much it's increasing. Looks like we're going 4 meters per second there. So in between these 4 meters per second. Down here, let's see, 2 to 4, so that one looks more like 2 meters per second. Let's do away with that one, put it down here. 2 meters per second. At best, that one is 1 meter per second. And maybe 1 meter per second here, because we know that that one's 0 over there. So if I look at that, that's hard to understand. But what I need to understand is by my 2 second point, I'm going at about 2 meters per second. And I'm traveling at 4 meters per second by about my 4 meters. So I would probably just go ahead and set it at a increasing of 1 meter per second on this and see if that's enough of a curve. It might not be enough of a curve, but that's okay. We can always go back and change it. So I'm going to see if it'll follow that curve or if I need to make it a little bit more severe, and that would just mean I need to increase that number. So let's try it out. Actually, that hits it just about perfect. And see in our next one, if you remember from previous videos, a downward curve means that it's going to have a negative acceleration. And notice this goes almost in a straight line for the first thing, so I might not start my motion or my acceleration until the 1 second mark. But that's all you're doing, is you're setting at what time your acceleration or your velocity starts, depending on what it says, okay? Very last one, velocity versus time, setting acceleration. This, I think, is actually easier because if we look at it, velocity versus time, the slope of a velocity versus time is acceleration. So as long as I can calculate a slope again, I have a nice straight line. I'm not dealing with a curved line, and I can figure out what I'm doing. It is important to remember, though, that velocity versus time does not show starting position. I do know if it's all a positive velocity, the little thing will only move to the right, so I'm probably going to move it as far to the left as I possibly can. That just gives it the most amount of room to follow this slope. Now, I just calculate that slope. 0, 0 there, 1, 1 there. Well, that one's an easy one. It's going up 1 and over 1, right? Up 1, over 1. So our slope is 1, meaning our acceleration is 1, starting at, look where the motion starts. The slope starts at 0 seconds, so that's where we're going to start it. So I'm going to put it at 1, and it's 0 seconds. Has enough room to move, follows it all the way through, and we're able to get that. This one, I can see it doesn't start to have a slope until 2 seconds, so I'm not going to have the acceleration start until the 2 second marker. So that's every one of them, and I don't know how I can be clearer if you're still not understanding that, so please give me some idea.